Video I will explain about fixed bias BJT. BJT means bipolar junction transistor. First of all, I will explain about basic circuit and parameters of fixed bias BJT. If you observe here with this transistor, fixed bias is also base bias. Fixed bias is also base bias. Here we are connected base resistor. This one is your base resistor RB and connected with the supply VCC. So here connected the collector resistor RC connected with the collector and supply to the VCC, connected to the VCC. So how this circuit function? Here we will giving input. Usually we will give AC input. Before we applying AC input, over here you connected a coupling capacitor here. See, this one is your input, and taking output, before you taking output, here we connected another coupling capacitor in the output terminal. The named as C, and this one is C dash, suppose C double dash. Coupling capacitor, before we taking output, we can connect the coupling capacitor output terminal, and applying input, you connected the coupling capacitor in the input terminal. That one is your base and collector is your output. Coupling capacitor means coupling capacitor blocks DC component at input and output. Here is the AC components are here. Derive few essential parameters. From this fixed bias circuit, we will derive few essential parameter. This is the input side. This is the input side, and this is the output side. First of all, we applying Kirchhoff's voltage law in the input side. Means this loop is the input loop. This loop is the input loop. Before we applying applying input side, we will applying Kirchhoff's voltage law, means KVL, in input side. The supply voltage of VCC, supply voltage is VCC is the positive terminal. Upset that we are observing base emitter junction, means base emitter junction voltage is VBE, base emitter junction, positive negative. Then after that we are observe base emitter junction, means VCC minus VBE equals to, then RB is the base resistor, and here after this, in this loop, the voltage across RB is IB into RB. Voltage across RB equals to IB into RB. Then here IB equals to VCC minus VBE divided by RB. Here this we can identify the input current IB. IB equals to VCC minus VBE divided by RB. VB equals to, here VB equals to forward bias voltage of base emitter junctions. Forward bias voltage of base emitter junction. In transistor made of silicon diode, the value of VB equals to 0.7. In case of germanium, the value of VB equals to 0.3 volt. In case of silicon, the value of VB equals to, in case of silicon, the value of VBE equals to 0.7 volt. In case of germanium, the value of VBE equals to 0.3 volt. So here from the input loop we can apply the Kirchhoff's voltage law. The base current is VCC minus VB by RB. RB. Then how? Then how output current will be observed here? Then same as apply the Kirchhoff's voltage law in your output loop. This one is your output loop. Here we can apply KVL in output loop. Then the supply voltage VCC minus the voltage across collector to emitter means VCE. Voltage across collector to emitter means VCE. VCC minus VCE equals to voltage across RC resistor is IC RC. How to identify then the output voltage of VCE equals to VCC minus IC RC. How to identify IC? How to identify collector current? In the manufacturing of transistor, we have a value of beta. Beta is the current amplification factor of common emitter configuration. So, based on beta, we can evaluate value of IC